I'm CK, and tonight we're doing a module from CuteLab out of New York. It's their Missed Opportunities probabilistic pattern generator, and it's actually not tonight. When I moved the files to my iMac last night for this build, I realized I hadn't recorded an intro, so this is the intro after I've built it. So the Missed Opportunities is again a probabilistic gate. So you feed a set of pulses in, say gate signal from a sequencer, and it will choose to pass or not pass some of those pulses. Useful for spicing up drum beats, useful also for other things the way this is set up with 4 outputs to change layers in a multi-timbral patch, and do lots of other interesting things. So what I was just mentioning is, besides being a straight probabilistic input or input to output, it also, things it skips, it passes on to outputs further on and other things. You can look at their website for a real detailed description of what this does. One thing I do want to point out at the beginning of this video for the first part of the build, I kept saying there was no build guide. There is a build guide. It took me a while to find it. I would suggest that they put a QR code or a link in their documentation that comes in the packaging, so a person knows where to look for that. Again, it's a relatively straightforward build and a fun little unit. Hope you enjoy the video.
Here's the bag. I also forgot to mention it's with no input. It's also a random pulse generator, which can be very handy. So let's see. I forget who I bought this from. I apologize. Maybe I'll put it in the description when I put it up online. Power cable. Little paper bag, which means I can recycle it easily, which is nice. Here's the panel and circuit board, I assume. Lots of tissue paper. Lots of tissue paper. Let's look at the front panel first. We've got this is a density control, which controls the likelihood of skipping a pulse and reset to restart the current thing. And then you've got inputs and outputs, I believe. I'll double check that. Now let's look at the board. There's a bunch of surface mount components already soldered on. That's too bad. I would have loved to do this. I like doing surface mount. Let's see, March 2022, so I'm recording this in May of 2022, so this is a pretty recent build. Okay, it's got instructions for soldering pin headers on this side, solder the jacks on this side. In other words, jacks go on this side, so there's a bunch of LEDs, bunch of jacks. The boards are good. All through-hole plated solder points. Let's look at the other board. March 2020. Trim pot, which sets the default density, and then apparently control voltage overrides, I think they meant, the value of this trim pot. Channel 1 random pulse generator, on or off. So if nothing's plugged into channel 1, or any of the input channels, then it'll be a random pulse generator. Couple of jumpers. Big control. It's Amtel Mega 16 Papa Alpha. Looks pretty straightforward. Except for the jacks, doesn't look like it has a lot of parts, but we'll see. Yep. Little piece of paper. Let's look at the little piece of paper. Oh, golly. Okay, it tells you what you do. I mean, how it works. All kinds of, oh, reset random seed. Okay, there's a random seed that you can reset. Good. Oh, that's interesting. 17, where is 17? Right here, miss and match. It's a switch. Changes the behavior of normalization between channels. When set to match, each channel is fed the output of the prior channel. When set to miss, each channel receives all of the gates skipped by the prior channel. If cables are connected to all inputs, it'll have no effect. That makes sense. That sounds kind of neat. So on the second case, on miss, so if I'm coming in 1 and I'm going bump, 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 and I miss the third beat, bump, 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 that missed beat will come down to channel 2, the way I understand what he just said. So that could certainly be interesting to have, say, a snare patch or on that one, and then a hi-hat module on that. So bump, 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 bump. Yeah, no, I'm sorry, I shouldn't be doing mouth noises. That's not my forte, but that sounds like it's going to be very interesting. Oh, I didn't look to see if we've got, I was going to say I didn't look to see if we have any values on the board, but quite frankly, there are no components other than LEDs, pin headers, jacks, and one switch. So I don't have to worry about values of resistors and so on, because there aren't any. So this will be a very quick build. I'm going to go ahead and get the soldering iron heated up, and we'll start putting this thing together. I was also just thinking this might be a fun module to use with CV to MIDI module, and say you have a complex multi-layered patch on a synthesizer, and use this to take layers in and out. They don't have a build guide per se, or at least I can't find it. It's not on their website. So I'm we'll be doing a little bit of guessing on this, which is okay. I don't mind that. So that's the backside. This is the I gotta see what we have for pin headers so I can match them up correctly. Seems pretty straightforward. They're all 3-pin pin headers, so that's easy to do. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There we go. Easy enough. Okay, there's all the... So there's a jumper here to turn the random pulse generator on or off, but I don't know how to connect that. We'll figure that out later. Let me see if it says something in the manual about that. I'm not sure, because normally I do something like put a pin header in here and then use a little jumper block to jump them together, and I don't see... Oh, and there's the jumper block. Okay, good. So That is what we're going to be doing. These two solder jumpers, no clue what they do. I'm going to put the trim pot, oh no wait, I'm sorry, I'm rushing ahead because I'm thinking instead of just doing. So let me finish up all these pin header points. Now I'm going to put the trim pot on. And this is what I was talking about right here. Here are the leads for the trim pot. There's one resistor, surface mount resistor there, and a surface mount resistor there, that if you're not careful, you could brush with your iron and dislodge them. What the heck? Let me get this leg, and then I'll do as I was just talking about with the pin headers, even though I don't really care if this is all that flush. No, that's fine. Now I'm not going to put the pin header there for right now because I want to make sure I have enough, but I am going to put the power connector, which goes, oops, come on Jack, let go. Power connector goes here, and it is not shielded or keyed, so you just have to be alert when you put the power cord on there that you get the red stripe in the right location. Sorry, I was just hearing a coyote. I was seeing how close he was. Okay, power connector's on. And that is everything for this board, I believe, even though there's a J24 and a J25 here that I don't know what they do. There's no mention of this in the build guide because there isn't a build guide and there isn't anything to reference. So we're just figuring it out as we go. And as we figure it out as we go, we're going to put this board here so we can figure out exactly where the female pin head or male pin headers, whatever. I don't think the pin headers have a problem with gender identity, but I'll be sensitive to it. Oh, that went on flat, huh? I'm surprised. Go ahead and put this one on here. Oops. Don't do it that way. Put the short pins through the hole, not the long pins through the hole, you silly person. Let me take a look here. See what we got. We've got all these match up, which is good. I'm not going to put them together right now, of course, but just giving it a test look. And I've got 2-3 pin headers left. I believe, again, this one here is for the jumper block that will turn the random pulse generator on or off. I don't really care if that one's straight up and down. It is, but I don't really care because it's just going to have a jumper block on it. It's not connecting to another component. Now that leaves me with one 3-pin pin header left over. Let me see if I can find a place where that might go. Now that would be a 5-pin, and that's a square or rectangular 6-pin. And there's nothing on here, of course. Oh, I gotta figure that out once I've got everything else on, and I'll take a look and see if anything appears missing. But first I'm gonna finish up all these pins, making sure I've got all the pin header pins soldered down, because yesterday I did a module and one function wasn't working, and I went back and looked and I'd missed like 3 pins on a pin header. So always double and triple check. I was wrong, I just checked. They do have a build guide, but it's in a location that I didn't look at first, so I'm just going back through and double checking that we've got everything on the way the designer wants. The only thing that is different is on his build guide, this pin header is a solid 6 instead of the 2 3s, but that doesn't obviously change functionality, so it's not a big deal. Now he says you can also, he has these other 2 pin headers that you can, if you choose, you can put in here to create an ISP junction to reprogram the board if you want to. I'm not going to be ever reprogramming this board, so I'm not going to do that. Now we go on to the control board. He talks about trimming down this metal shielding on the jack so it sits flat on the board, but only one jack appears to have metal shielding. The others are simply plastic, which is great, but I have to go get my carbide tip cutters for this. Just a little hint, or a little suggestion is invest in some carbide tip, carbide jaw cutters. They will cut through anything. Oh, there are two of them actually. They will cut through anything without damaging the jaws of the pliers. If you use your regular wire cutters, there's a very strong possibility that you will damage the cutting surface of your pliers, and you don't want to do that. So get some carbide tip cutters. Now they're not cheap, however they will save you money on the other pliers not being damaged. And also, in the grand scheme of things, a pair of cutters like these are Schmidt's out of Germany, they'll last forever. So it's a long-term investment that you're making. There are a couple of different carbide tip tools you should probably have. I should probably do a video on that at some point. Okay, the next thing to do is to take all the panel nuts off. Okay, now we're going to put all these guys on, and these metal back ones are at this end. These don't go in these holes very well, And I said it's kind of funny because on his photograph and his build guide, this is all tilted, so obviously he had his own challenges getting that in. Where did I put the other one? I just had it. There it is. Been a snake, it had bit me, as Buckaroo Banzai would once said. So what I'm gonna do what I do. It's not what he recommends necessarily, but it's the way I like to do this. I'm gonna do one pin on this jack. And again, be very careful. This is where you're going to have to be really careful, because as you can see, there are surface mount components right next to it. Gosh, that didn't take solder at all. So as you're soldering any of these, you have to be really careful not to brush up against these resistors. And I use, as you can see, I use a 30-degree bent tip on my soldering iron. And what that, I like it very much. However, it can accumulate a solder ball right in here as you're working, and you can accidentally dribble it onto other components on the board, and surface mount components on the board particularly. Now I'm going to do one leg of this one also. Now we'll take the front panel, which I put somewhere, put it down over everybody. This is where our little pokey thing comes in handy to do final adjustments. I'm not doing the LEDs yet, just doing the jacks and switches. So the two jacks that I put some solder on, I will put a panel nut on each of them. To get the whole assembly flat and hopefully parallel. The front panel should always be parallel with the circuit board. Of course, that's not always the case, because sometimes components, people purchase different components for the kits and they don't quite fit and whatever. Now the key thing I want to check right now is, okay, that switch switches without interference. It's not rubbing against the hole, it's not binding. It's good. Mix and match goes. Good. So I'm going to solder all the jacks. Actually, I think I'll go ahead and solder all the LEDs at the same time. Get them all lined up in their holes. Fully inserted. The yellow ones seem a little slightly larger diameter, and this LED right here, if you can see, it's at a slight angle. It doesn't go straight down into that hole. Not a problem, just something to notice. If it's not going in quite the way you think it should, that's what's happening. I'm going to flip my solder pad over so I can get the switches to drop in little holes on the solder pad so everything lies flat. Now I'm going to solder all this up, and I'm going to do that in fast motion with no commentary, because nothing much to say about this except a bunch of soldering. Okay, so that's everything soldered on, and I'm going to say this again, be very, very careful with your iron. There's not a lot of room to get into some of these, and you can be right on top of these surface mount resistors and knock them off without even knowing it. I'm going to take a closer look here and just verify all my solder joins. Because on a board like this, it's easy to miss something. It's also, some of them didn't flow quite the way I wanted, like this one. This one needs a little touch up. And again, I've got a transistor and a surface mount resistor right next to this. So you want to be very careful. There we go. And I use an index card when I do this, so I'm only looking at one line of solder joints at a time. I'm not overwhelming my visual processing center. Okay, I missed that one. And that one, I missed two of the switch terminals. Again, that's why you double check. As you can see from my channel, I've successfully built nearly 50 eurorack modules in the last 6 months, and you can still make mistakes, so just be careful. Double and triple check your work. Okay, so I think that's it. I'm going to put the jumper on the on pins like so, because I do want the random pulse generator. That sounds like it'll be fun. Now let's go ahead and mate these. And I have all the pins in the right places. Looks that way. So we'll bring it home. Yeah. Try to bring it home. There we go. That all goes together very well. Nice and solid. Now I'm going to spin all the panel nuts on. Now we'll put the power cord in, and again, since it's a non-keyed connector, make sure the red stripe goes to where it says stripe, and also where the negative 12 volts is. Jumper's there. Okay, so there it is. It's the front, side, back, other side, top, and bottom. So it's ready to go in the test rack, and we'll see how she does. Okay, so she's in the test rack. We'll power it up and see what happens. We got blinky lights, which is always a good sign. So I'll tell you what it's doing in a second, but the Division 6 sequencer is going to be feeding the VCA, and we're using an even VCO from Befaco for the oscillator. And then that will be going into the missed opportunities, and we're going to come out number 1 first and see what's going on. But what's going on right now is, because I don't have anything plugged in to input 1, as you can see on the scope, it's just producing a random pattern, which is pretty neat. We'll listen to that in a little bit, but first I want to do the first things first, the original sound. So if I turn on the Division 6 sequencer, on the scope you can see the yellow line is the Division 6. I'm going to unplug this just so it's not distracting. The yellow line is the Division 6 pattern, and it's pretty standard, just a little 6-note sequence. So now I'm going to take that, I'm going to turn the volume all the way down, I'm going to take that out and plug it in to input 1 here. And as you can see, now the behavior's changed. So I've got this on match, so it's passing through everything. I put it on mist. So this green LED is showing the input from the sequencer. This will be the output, and I'll take the output from that and put it in to CV in for the VCA, so we hear what happens. So now we plug this in. As is pretty graphically evident, we've got some pulses coming off the sequencer that are being completely dropped or missed, and those misses are being passed on to these other outputs, which is very interesting. If we go to the other way, the ones that are passed go through. Read their manual, it's probably clearer than what I'm saying, but this switch is very interesting, because if I wanted to take that, well, I don't have anything to take that to, but you can imagine you have a VCA, which this one may be controlling, say, a bass drum, and you have another VCA controlling snare or hi-hat, so you have the bass drum going here, and when it misses one, it'll pass it on to the snare or hi-hat or accent, whatever. Or for different layers, as I talked about a little bit earlier, you could hand it off. If you have a multi-layer patch with, say, a sine wave and a square wave on it, and you can alternate between which waveform would be triggered. So that looks pretty good. I mean, it does exactly what it says it's supposed to do. I'm going to hit the reset button, and that redoes the random seed. So that's definitely a different pattern. So I'm pulling a different pattern just from simply pressing the reset button. So when you're doing something and you want a little variety, you just hit the reset button, and you're going to get a new pattern. I'm going to speed this up. I'm going to see how fast this can go. Goes pretty well. Keeps up pretty well. Now I'm going to do what I said, what I was talking about earlier. I'm going to pull number 1 out, and now this is simply what we're getting
is simply the random probabilistic generator inside of the missed opportunities. And we can reset that too. Now we're getting a little funny sound just because the sequencer is still running and blending notes. Let me fix that. I'm just going to go ahead and take the CV output out of I can't do that because I don't have anything else to trigger that with. Let me do it a different way. I'm going to take CV from my MIDI keyboard. So you can see that's going on. Try another output there. It's an interesting unit. So again, it's a pattern generator all on its own, which is it's very interesting. So it combines two. I have other pattern generators, but this combines a pattern generator and a manipulator of an input pattern. Let's go back to that. I'll go back to plug CV back in the right place. Drop it down to another output, and that's the third one, so it's cascading down, so it's often not gonna, it's not gonna get triggered very often. And if we go all the way down to the fourth output, you're not going to get very many pulses at all. As it cascades down through all of them. When I have it on pass through for everything that it triggers, that's different. So that's what it does. It's pretty neat. A couple of things, of course, during the build. It's mostly surface mount, and it's mostly already done. So the build is pretty much just the mechanical componentry that you have to put together. Some tight soldering, so you need to be careful around the surface mount components. But, and again, I don't have anything going into reset or density, so we haven't tried those, but I'm not going to do that because reset is pretty much doing the same thing as hitting that button. And density, let me try some. It doesn't hurt. I just plugged in my ADSR, and right now, I'm hitting the trigger button for the ADSR, and as I hold the button down steady, that's sustain is still sending voltage out to density, so it's giving the full pattern that it thinks it should, that it's determined it's working with. But if I don't, and then when I release that, and voltage is at 0, it just goes away. And then as I hit the trigger again, it goes through attack, decay, and to sustain, it comes back in. So that's something interesting you could try too. Use an ADSR that you're triggering from just some random place and to another pattern, say coming from another sequencer. I mean, there's lots of things you could do here. So it's a fun little unit, relatively inexpensive. It was less than $100 US, and it does exactly what it says in an interesting way. Hope you enjoyed the video.